So my name is Lily Winfrey, and thank you so much for coming today to this Fellows Workshop. We're really excited to be presenting. I'm the product manager of the Frictionless Data for Reproducible Research project at the Open Knowledge Foundation. And I'm also in charge of the Fellows program, which you will be hearing more about today. And you'll be learning about how these 4 amazing fellows have been learning how to make their research more reproducible. So I'm also think there are some people that might be waiting to get in. Can the other fellows monitor the?
I'm on it.
Okay, thank you.
No problem.
So I was going to start by talking a little bit about how this is a virtual workshop, which is a new experience for most of us. Originally, each fellow was going to give a workshop at their institution, but that all had to be canceled. So there might be some issues that we encounter today, but we're all going to try and have patience with each other and work together. All right, so with that, I'm going to go ahead and get started. So I want to tell you a little bit about the Open Knowledge Foundation, which is where I work, and we are supporting the fellows. The Open Knowledge Foundation is a nonprofit incorporated in the UK, and we just had our 15-year anniversary. And our focus is on a fair, free, and open future. So imagine a world where all non-personal information is open and free for everyone to use, and where we've also empowered people to use that information. So we teach people how to use open information, open data, and then they can use that to make society better. And that's really all that I want to say, because this workshop is about the fellows. They have done all of the work themselves. They've prepared the workshop, and I've been sitting here and had the pleasure of just watching them create this. So now I'm going to hand it over to them.
Hi, everybody. I'm Cele. I hope everybody's safe and sound wherever you are located right now. I'm part of the cohort for the Frictionless Data Fellowship. And I'm going to talk to you a little bit about the program and what is the Frictionless Data Project. It's an open source project that has the tools from the Frictionless Data ecosystem. We aim to have more open and more reproducible research, and for us to understand and integrate data in our work, in our data science in our work, right? What is the Frictionless Data Fellowship? It's a gather of tools and specifications and also methods that we can use to have a more reproducible research and be able to reproduce and to share the findings that we have during the work that we do researching, right? It's also coding, writing. It's a lot about capacity building with each other and discussions in how we can make this like a better ecosystem for us to work in. It's all of the frictionless data tools and methods can be used for tech people, also for non-tech users. And that's a little bit about what we're going to be working on today. So next slide, please.
Hi everyone, I'm Lily. I'm one of the fellows. I'm an interdisciplinary marine science PhD student at University of California, Santa Barbara. And through my research, I study how coral reefs and coastal communities are affected by global environmental change. And I'm interested in building resilience in these systems. And I see the tools that we're going to go over as ways to speed up my ability to collaborate with other scientists and understand these issues faster.
Hi, everyone. Thanks for joining. My name is Monica Granados. I'm one of the fellows. I have a training as a food web ecologist, but I've transitioned into working in policy, specifically open science policy. So when the opportunity came to work on this project to learn new tools that then I could share with some of the scientists that work for the federal government here in Canada, I jumped at the opportunity, and I'm looking forward to telling you about what I've learned.
Hi, everyone. I got to apologize foremost is that you might not be able to see me. Having internet connection issues. Nonetheless, my name is also Daniel. I'm also a Frictionless Data Fellow from Kenya. My research background is in infectious diseases, which are vectored by arboviruses or by arthropods. And also I've done some work in wildlife conservation. My background is in molecular biology and bioinformatics. And so getting into the Frictionless Data Fellowship was an opportunity for me to just get to understand how I can be able to handle my data flows in a more efficient and reproducible manner, and also in an open manner. Now, today I'm going to be taking us through the introductory part of the first session of the workshop today, and I look forward to having some good time with you. Otherwise, you can also find me at my Twitter handle, also Danos. Talk to you later.
Hi, everybody. I'm Cele. I'm also part of the Frictionless Data cohort. My research background is in social communications. I'm a PhD candidate in social communications as well in the National University of La Plata in Argentina. I'm Nicaraguan. And my research topics are an intersection between gender, feminism, communication, and open geospatial data. Thanks, everybody, for joining us today.
So our objectives of this workshop are to do a hands-on introduction to two frictionless data tools, the data package creator and also good tables. And so the data package creator is used to package up your data. It allows you to include the metadata, such as the name of the package, its license, its publisher, as well as list the forms of your different data resources. And also included in this data package will be information on those files, like size and the schema. And then the second tool is Good Tables, and it was developed specifically to help with tabular data validation, and it's available as a web tool, as a Python library, and through the command line. And Good Tables can be used to check the structure validity of your data as well as the content validity of your data. And also during this workshop, we hope to communicate the importance of good data practices and learn more about metadata. So our expected outcomes will be that by the end of this, using the web interfaces, you'll be able to create your own data package, and you'll be able to create a schema file as part of that data package and use it to validate a data set using good tables. And you'll also be able to handle common errors in the frictionless data workflow. So everybody all together, we're going to do a hands-on practice of these tools using one of my own data sets that's available online on my GitHub if you click on that practice data set link. And this data comes from one of my PhD projects, which is focused on increasing the local benefit of research in Maria, French Polynesia. So when it's conducted by foreign scientists, these interviews are about whether we can improve that relationship between local residents and scientists. So it contains anonymized interview data for 160 individuals. That's 105 residents and 55 scientists working in Maria, French Polynesia. It contains demographic data, data on each respondent's perspectives of local marine management, also columns based off of what they consider the most important components of life to be, and their opinions on the relationship between scientists and residents, as well as it includes their perspectives on whether certain topics should be considered research priorities for scientists to study. like whether they think malnutrition or coral bleaching should be priorities. And if you want to learn more about this data set, you can click on that bottom link and read one of my blogs on it. Next slide.
All right.
So,
Thank you, everyone. And I'm going to take you through the introductory part for the first tool that Lily talked about, that is the data package. And in any case that my internet, as I mentioned earlier on, fails me, then my colleague Sele will swiftly come in. Now, imagine when you were planning to attend this particular workshop, and there are certain requirements that were required of you to have in advance that you may be able to attend. For instance, you need to register, and then you need to have a computer. It could be an iPad, a phone, maybe you got some notebook and a pen. And so you package yourself in a manner that will effectively allow you to benefit mostly from this particular workshop. And therefore, when I'm talking about a data package, then I want you to picture such a scenario that perhaps you're walking into a supermarket or a retail store and you buy different items. But then when you want to get away, you cannot be carrying all these items in your arms or balance them on your head or something like that. You need to be packaged for the particular items that you bought in a manner that is convenient to carry. And so such is a data package. It is a container that allows you to efficiently, effectively, and conveniently package your data or carry your data. And so that way you can be able to move with it from point A to point B. And so inside the container, which is our data package, there is the data, which you could be having in your local machine, or you could be having it in a remote space somewhere in the web. And it also comes in varied forms. Some of the very conventional forms that we have are like the CSV that most of us, if not all of us, have been able to experience. The next thing that a data package contains is the metadata. The metadata is the data about your data, a description of your data, and is an important component of the data package, because with your metadata, it then means that a foreigner or an external person coming into your data can be able to understand your data, how you collected it, how should they use it, what licenses are associated with your data. And therefore, this can allow them to also make meaningful analysis or draw meaningful information from your data. The third and the last thing that the data package has is something called a schema. A schema is kind of a blueprint of sort that allows you or points you to certain attributes of your data. Think, for example, you've several columns of data, and they contain different information. Perhaps some of the columns can only contain numbers, others only contain strings, others only contain dates. These are things that you can control for. And
Okay, I think we lost you. Sally, do you want to take over?
sure. Here, there he's like, and so,
Lily, all
are
right.
you there?
Yes. Now, why do we need a data package? And I have alluded to this in the previous slide. And the reason for which we need a data package is for conveniency in transportation. You package your data in a manner that is easily transported. It's efficient to be transported. It is light, as only the bare minimum that is required for your data. And again, it allows us to reduce friction. reduce to the bare minimum friction that is there in the processing or in the workflows with data. And these we're going to see later on how it can be achieved. The third thing is that there is a reproducibility aspect of the data, and reproducibility allows somebody else to be able to do the analysis that you've done in your data or perform an experiment that you've performed based on the information that you've provided and get similar results as that which you got. And so since there are specific specifications that a data package has, it then allows for reproducibility. An aspect of reproducibility that we're also going to look at is the interoperability of a data package based on the format of it. The last thing is to validate. You know that when data moves from one point to another, there is a chance that it might be corrupted for whatever reason. It might be a sinister motive by some external person, or it might be an accident. You probably erased some data that was in a cell by mistake without noticing. And so from time to time, you need to validate and ensure that your data is in the right format, even for the analysis itself. Rolling to the next slide. Creating a data package. Now, for this session, we are going to look at a web browser or a GUI tool, a graphical user interface tool, that is called a data package creator. My colleague Sela is going to take us through this real nice in a moment. And so this is an open source tool that is web-based, and so there's no restrictions. You don't need to sign in or do whatever registrations to use it. You simply get to the link, and it's quite interesting and intuitive to use. But also there's an advanced option, which is programmatic, and also it comes in different flavors of programming languages, from the shell, Linux shell, Python, R, Go, Java, several other languages are supported. And this is also important, especially in automated workflows in which you need to code your data validation or data package workflows within a certain script or pipeline. And a data package is outputted in a JSON format, which is a JavaScript notation that allows us to, that is quite universally used across systems, across platforms, whether it's web, whether it is other different tools for data analysis. It's quite a universal format of data. So the data package creator outputs for us a data package in the .json format. And to give you a snip view of how it looks like, I'll roll to the next slide, which has a picture of the data package landing page. Now, when you click to a particular link that you will shortly see, this is where you land. And in a summary way, the left side, the leftmost pane, is the metadata pane, which contains information about your data. And then there is the middle part that is called the resources pane. And then there is the right side, which is called the JSON schema pane, where you can be able to see the schema version of whatever is in the resources pane. And so those are the three main components of or sections of a data package creator. And I'm glad now to hand you over to Sela, who's going to take us through step by step show of how you can be able to create a data package using the data package creator. Sela, take it away. Thank you.
Thank you so much, Uso. Remember that you can always send us any questions that you might have to the chat, and we'll be monitoring that. So I'm going to give you the grand tour over the data package creator website, but first of all, I'm going to give you like a little detail on the 3 panes that Uso just recently showed you. As I understand, many of you already received the email where you have all the links that you can access to for you to get to the frictionless data tools. So if you want to go ahead and check out the data package creator at the same time that I'm explaining it, that's perfectly fine as well. And yes, so first of all, on the left side, as Uso was saying, there's the metadata pane. And what kind of things that you can find there? You can find different different sections of what you can put there for the data of your data. So you can put the name of your data, of your data collection. You can put the title. You can put what kind of profile that has or what kind of data standardization it has, a description, and all of the information that you want to have and that it's going to be reflected on your JSON schema afterwards, right? And on that same pane, you can find for you to upload your data, also to validate it. And afterwards, when you have your data package created, you can download it into a CSV file or a JSON file. And also, you can add some keywords that for your information and for your data package to be more easily found. So next slide, please. And don't worry, then we're gonna get our hands on the platform, so it won't be just me talking, it's going to be you using it. And on the right, on the center part of the platform, you're going to find the resource pane, and from there you can add the name of the resources that you're adding, and that will be your data and the data collection that you're uploading. It can come from either an URL from a cloud, that could be from a GitHub page, or for any other open data website. And you can also upload it from your local computer or your local server. Also, what you can add there are different fields. All of your columns from your data set are going to be there described in different fields and tabs that can also have different kind of information. You can add a title for each of your columns. You can add a description. You can add many other format and characteristics and categories of information that you want to have there. Also, after that, you can add more resources. And one thing that it's really important for us to point out is that sometimes you might get an error, which is the most common error when you're uploading your information and when you try to validate it. It's the error that you see there on the slides. And that happens mostly when it's like a bug that whenever you put on the name of your resources or the name of your data package with special characters or maybe with capital letters, it's going to give you an invalid data package message error. So for that, like a quick hint is that always use lower caps and also use maybe just one word, the simplest that you can, for you not to get any kind of errors. And next slide, please. And on the right side, which is the last part of the platform, is where you can see the schema that's being automatically generated by the platform whenever that you're adding information and whenever that you're adding the resources and the characteristics of your resources. You can see it on the right side generated in a JSON format. Why it's in a JSON format? It's because it's machine readable and all programs can understand it. Computers and machines can parse with that format, and anyone can use it in any kind of software. And one of the errors that you might find when working with your schema is that the whole schema that you see reflected on the data package creator platform, it's a whole set of lines, of coding lines, but for you to actually have your schema, you would only select a part of all of that information. Can we go to the next slide, please, so people can see it? Thank you. As you see there, that's an example not from Lily's data, but from Lily from the Frictionless Data, from the Open Knowledge Foundation data. And where you see there is that you actually only select the part that comes from the fields line, and you get the curly bracket until you close that bracket at the end. And then you can save it in a JSON format with any kind of text editor. You can use it with Sublime, a Notepad, or whatever kind of text editor you have in hand. So on our next slide, many of what you already said is why this is so important and why is it so useful, not only for us, but to benefit other researchers and other colleagues, and to enhance and to help with the reproducibility of our researches and our findings, and the importance of actually open up science for more people. So this helps us to have more precise data archiving format. It easily shareable. It helps us to reproduce the data and the findings that we have from our work. It also goes by the fair, I never know how to say this, I'm sorry, fair, I forgot, but it's okay. So it's findable, accessible, interoperable, and reusable. And it gives you data integrity validation as well. So we're gonna go on our hands-on time, but I don't know if you have any questions first before we go into the depth of the platform. Yes? No? Principles. Thank you, Jonathan. That's it. For principles.
So if you have any questions, just unmute yourself and ask away. Or if you feel more comfortable, you can ask the question on the chat as well, and we can take it up.
And now we can go to the next slide. And I'm gonna ask all of you to go into those two links there. The first one is for you to access the data package creator tool, and the other one is for you to access Lily's GitHub so we can start working on the data.
And in case you're not aware yet, the slide was shared also on the chat, and so you can just go over there and click it and open to follow along so that you can quickly get to the links.
And I'm going to stop sharing so that one of the fellows can share their screen now to get into the hands-on time.
Thank you. That would be me. Can you all see my screen? Yes, awesome. So we're going to go to the data package creator. Is everybody there already? Yes, no, hands, chat, yes. Awesome, and I'm also going to need you to go on the, I'm sorry, that's my part, that's my roommate. Now I also need you to go to Lily's GitHub, please. One second.
So we'll just take this time to make sure that everyone can go to the GitHub page. Yeah, we've got it. So while we're just sort of waiting to sort that out, we've got a question here that I really liked. Someone asked, does this help? We're talking about data packages. Does this also help provide data documentation in addition to shareability and reproducibility? And yeah, like I think that it was really a way that I found that this tool was so exciting about this tool was that basically it allowed me to give context to people when I'm sharing this data. And so I really like that for every resource, essentially for every column of your data, you could give more information other than just like what the column title is. And so it really does give you more documentation about that, and you can give licenses to your data. So we're going to go into that a little bit with Sally. So if you've got any other questions, pop them into the chat, and we'll take them on. We'll take them on and address them as the workshop progresses. So yeah, everyone should be here on the GitHub page. There's a question here that came up about the type of data that you're going to be able, how can you upload the data? So you can do it by CSV, or we're going to show you how to do it with the URL link. So Sally, back to you.
Awesome, thank you. I'm sorry for that hiccup that we had. Okay, so we are on Lily's GitHub, right? And we're going to go down here to the resident researcher data.csv, I'm sorry, and we're gonna click on that. And for us to actually upload this data to the data package creator tool, we're gonna go to the raw button. And from there, we're going to copy that link and go to the data package creator, right? On the resource pane, you're going to paste it, and then you're gonna go to the load button. And now you see here that it says add all inferior fields that has 19 extra columns. So you just go and click on here, and then you're gonna see it there. Everybody's there? Yes? Kind of, yeah, no? Any questions, any problems so far?
Why don't we get—
Yes, yeah, hello?
Yes.
Hello. Please, I have a little question. Now, the question I have is this. The raw data, I downloaded it in Excel as an Excel file. Can you hear me? Yes, I downloaded it as an I downloaded it as an Excel file. So where can I add it or upload it from this data package creator? I'm at the interface now. Instead of pasting, because what you did was that you copied the raw data and pasted. Are you with me? But mine is in Excel. It's in Excel. It's in Excel. I downloaded this in Excel. So now I want to upload it in this data package creator instead of pasting it.
Okay, you already have your data then as a file in your local computer,
yes,
right?
Yes, as a file, yes,
Awesome.
Exactly.
Then all you need to do actually is go here at the same type resource page, and you go to load before, and it's gonna prompt this.
You mean at the resource? Please come again. The first thing said I should go where? Hello?
Yeah, so
Yes.
You will just take it slow. So you did it, you're sort of asking a different way to upload. So Sally is showing you that if you click the load button, it's going to open up it's going to open up a window. That's
upload. The upload button. Okay.
Basically.
Okay.
Yeah, it's basically the upload button.
Okay.
So it's going to open a window for your local drive.
I understand now.
And then you can load it that way. Yeah, so there's just two different ways you can do it. Okay, thanks for the question.
All right.
Awesome, thank you. Anybody else? You're welcome. And thank you,
there's
Monica,
another question that
in.
came up. No worries, there's another question that came up here, and it says, what was the last button one clicked on? I had other screens up and I only heard, then you click here. So maybe we could just show, why don't you reload the data so that the one of our participants can just see the process again.
We're gonna do it again. So we are on Lily's GitHub, right? Everybody see it? Yes? Nodding heads? Yes. Awesome. So we're here, actually here. And we go to the resident research data.csv. It's gonna open up the file. And we go on GitHub on the button that says raw. From there, we click, we go to here to copy that URL. We copy it. Then we go to the data package creator platform, right? And where you see the word path on the resource pane, you're going to type there or paste actually the URL that you just copied from GitHub, okay? So it's there, and you can see that it's a .csv URL. And then you go to the button on the left, on the right, I'm sorry, that says load. So you load it there. And again, on the resource pane, you're going to see that it says here, add all inferred fields that has 19 extra columns. So you click on there. Is everybody with me? Yes, no, yes, awesome. Anybody had any problems?
Sounds like our folks are on board.
Awesome, awesome. Okay, so now, let's go now step by step again. So you go to name and you put the name of your data collection. And as I told you before, if you try to validate this in a way that you have special characters on the name or caps lock or anything like that, it's gonna give you an error. So let's see first the error that can give us. If we go like that, something, something, and you go to validate, it's gonna give you the error that I was telling you about here. It's gonna tell that your data package is invalid. That's the most common error that at least on the program we found. And so for what you need to do is just change the name and put on test data all together and in lower caps, and then you go to validate. It's gonna tell you that your data package is valid. So this is the first part. You put the name of your data collection, so test data. You have your path, and then on the left side, you're going to see the metadata pane that we were talking about earlier. So we put the name again. I'm sorry if you're seeing all of that. I put the data dummy. The title for your data, it could be workshop data. And then what kind of data you have. Mostly we work with tabular data, and this is the outcome that you're gonna get. A description of your data. This is a data set for our workshop, right? From here, you can add from where you got your data from. So we're gonna go to, I'm sorry, to Lily's GitHub page. Back again. And we're going to copy that so we can thank her afterwards. That's the first version of your data collection. The author will be Lily. The license, we try to have the most permissive one, but at the end we want also people to credit, for example, Lily's work. So we're going to use the CC BY 4.0. That's for attribution. That means that you can use the data, edit it, reuse it again, but always acknowledging the fact that Lily is the one that actually created the data set. And you can add some keywords. So it could be Maria, which is where we got this information from, Frictionless Data. And so other keywords that you want to use, right? And here, give me a second. You can see here the information that's being created for your schema. It's automatically generated here. So as you can see from the information that we put, the name would be test data, the path from where we got it from, the profile, the fields. And in here, as you see, you can add different titles to all of your fields and to all of your rows. So this is the document name. We can add here that these are the IDs and the description we can put. And as you see, it goes here. Whenever that you put the information description, this is something. And you see it here being automatically generated. And the data type. Yes.
So what's the difference between name and title?
For that?
For a field. So name is a machine readable name, title is a human readable, I guess?
Yes, I'm gonna say yes. Lily, would you back me up on that?
Yes, and also oftentimes the name will be the name, like the header name that the data comes with, and then you can use the title field to add in a more descriptive name.
Thanks.
And after putting all of your information, you validate your data package. See, we see it's validated already, and we can download it. It's going to give you a JSON file for that. And for you to get your schema, all you need to do is select from here, from your first curly bracket, all the way down to your last closing bracket. You copy this and you put it on your text editor and you save it as a JSON file. And after that, you will have your data package created, and you would also have your schema created for that data package that you can validate later on using the goodtables.io platform and tools. And now we can go to questions again for this. And I'm gonna stop sharing my screen, so I'm gonna hand it over back to Lily.
I'm gonna read off a question that some people had, which is when you're looking at the data package creator, if you don't see the JSON panel, click on the right side, there's a curly brackets, and you can click on that and it will expand open. And hold on, and I will share my screen again.
Also, I saw an interesting questions about whether or not there's some functionality with Google Sheets. And I thought, yeah, that's a really good question, especially when you're trying to think about sort of like any sort of continuous processes. Lily answered that there is the beginning of some work being done for working with Google Sheets. Conceivably, you could also use R to use that workflow. So if you pulled in your data from Google Sheets onto R, and then you use the R functionality for the data package, that's a way for you to sort of marry those two different tools together within the R programming language. So that could be a way that you could get started on that until there is sort of a native functionality.
There's also a question on why.
Go ahead.
Yeah, there's also a question on why Sele only selected the schema part and not including the keywords and the metadata. And I won't try to pronounce that name because I might murder it. So bear with me. The reason is that the schema section that Sele just showed us is useful in helping us with validation, as you will see in the next section of the workshop. And so that's the reason why she only picked that part, which is basically picking the opening from the opening curly bracket to the closing curly bracket of the schema key and saving it separately. You'll see how that will be used later on. Thank you for that question.
So see, there's also another question about, do we need to convert JSON file into CSV while working? So if you're working in the data package creator, you would be uploading, like if you wanted to upload the data with all of that metadata information, all of that context, then you do need the JSON file. And so you could imagine that, you know, you're working with a colleague who is working in a different city than you, and you're working on a project together, and they have some interesting data they want to give to you to add for a meta-analysis. So if they send it to you as a JSON file, you can open it in the data package creator, and you can have a look at all of that metadata information that is packaged along with the CSV file. And then later, once you have like the JSON file, you can take out the CSV file as well if you wanted then to take that CSV file and then integrate it into your workflow. But receiving it as a JSON file is really neat because it's giving you all of that context, not just the CSV tabular data.
We're also showing you an example with only one data set, but you can use the data package creator to upload multiple data sets and describe multiple data sets. And where it says resource, every resource that you add, you can think of it as a different data set that you're adding to your package.
Great, okay. I think, should we move on?
Sure thing. Yeah, so keep the questions coming, and we'll keep answering them as the workshop progresses. Okay, so hi everybody.
Sorry.
I'm once again Monica. We're just gonna wait to get back.
Yeah, hold on. Sorry.
No worries. So I'm going to tell you a little bit about good tables. So you've been learning about the data package creator, which again is a way for you to think about, you take some data and you try to give a little bit more context to that data so it's easier to share to potential colleagues or just to anyone who's interested in the type of work that you're doing. So now we're going to strip it back a bit and look at the data itself, the tabular data. So when we're talking about tabular data, think about it as, you know, sort of like rows and columns. So where you've got every row is an observation and your columns are some kind of descriptor. So when you look at a tabular data set like that, you think it's usually pretty complete. Every column has the same type of data type in there. You're not missing, you know, you're not having any sort of weird entries, except, you know, you might know that for your own data, but say you're receiving, you're going to give someone your data or you're receiving new data, it would be really great to know if the tabular data file that you received, in, for example, the CSV file, has any sort of, you know, has any like weird entries or any missing data. Wouldn't it be great, instead of doing like Control F in Excel and looking for like blank spaces or like weird entries, you could have a tool that would do that work for you. So we're going to talk about good tables and what good tables and how good tables can help you validate that data, do that work for you. So validating your data is really great, just not only for like your own data. So when you go out into, say, the field, or you've just finished an analysis and you input data, you want to make sure that the data itself is robust. Or if you just received some data, you also want to sort of check that it's robust. So you want to look for data integrity. Are there any errors? Is there any corruption? Is there any columns that are missing? Are any sort of blank? Are there any blank entries? It helps with reproducibility. If I want to share my data, I want to put it through some kind of validation process to make sure that I feel comfortable sharing this information with a potential colleague. It also helps a bit with the pre-analysis. So if I'm about to do, I've just finished my field season, I collected a bunch of information on fish or on octopus, and I'm trying to start, the first bit of my analysis, I want to make sure that it's robust before I move on to the plotting stage, when I start to sort of to make graphs of my data. So all of this is just a really good step to integrate in your workflow when you're working with data. Okay, so next slide. So this is a screen cap of the trygoodtables.io webpage. So as in the previous tool, we're going to do a walkthrough, but I'm first going to give you a little bit of introduction so that you feel more comfortable when we start to play with good tables. Okay, so it's a pretty simple interface, and that's great, because really what we really want to understand how to interface with this graphical user interface. So you can either upload the source of your file, so very much like what we did in the data package example, or you can upload the schema that you also got from your data package creator. So depending on where you are in your workflow, so you could imagine if you, again, just came back from the field and you've inputted all your data into a CSV file and you want to see if there's any missing data, then, and you only have your CSV file, then you could upload it through the source here. If you can imagine now, instead you were receiving a data package or you had built your own data package and you want to make sure that the schema matches the tabular data file that you have, then you can upload the schema. So there's two different ways for you to validate the data. Remember, we're going to be doing a hands-on example. So this is just a little bit of an introduction to the tool. So next slide. So as I mentioned, just a broad outline of the Good Tables tool is that there is two ways to add your information for validation. You can upload that raw CSV file like we did in the data package example, or you could upload your data as well. I know that question came up earlier, can I upload my data? You can do it that way. And if you want to sort of compare your schema to your tabular data, then we can also upload the schema itself. We're going to try both so that you can have a look to see how to do that in the Good Tables tools yourself. Of course, we're using data that we've provided, but we encourage you to try with your own data after the conclusion of the workshop. So next slide. So another neat tool, another neat aspect of this tool is that there are two different types of validation. We're going to be showing you the one-time validation. So that is, we're just going to look at sort of the static version of your tabular data and to see if it has any errors or any missing data. You also can use the tool to do continuous validation. Now that's probably more helpful for you, especially if you're working with data that is changing. You know, maybe you're adding new observations, maybe you're adding new sites that you're sampling. That's usually how most of us work with data. It's usually not very static, but there is built-in continuous validation. We won't be going into that today because that's sort of a more advanced topic, but at the end of the workshop, we're going to be giving you a lot of other links for you to have a look at the tutorials to learn how to take it from a one-time validation to a continuous validation. So like I mentioned, we're going to be doing just the one-time validation using the raw data link and using the schema. It's going to be, so what type of errors is this going to be looking for? It's going to be looking for structural errors and content errors. So it's going to be looking to see if there are entries that don't match the schema, if you're using the schema, and if you have sort of any missing content. So if you've got some, rows that are, or a cell that doesn't have any data. We'll show you that in the hands-on example. We'll do an example with an error so that you can see how this tool will catch errors that you may not be aware are in your data, but that you definitely want to catch before you share this data or you proceed doing any type of analysis that may lead to spurious conclusions. Next slide. Okay, so I'm going to hand over the metaphorical mic here to Lily Zhao. She's going to take you on a hands-on example. So we're going to be using the same data, the data that she herself collected, and we're going to validate the tabular data file that you've already seen in the previous data package example. So take it away, Lily.
I'm gonna stop sharing, so Lily, you can start sharing. And Lily, you're muted.
Everybody see my screen? Awesome.
Looks good.
Great. So right now, if you click on those two links in the slide, maybe someone can put them in the chat. You should have up the trygoodtables.io, which is the interface we're going to use Good Tables. And then you should also have up my GitHub page. Great. Is everybody there? Awesome. So the first thing we're going to do is on my GitHub, we're going to go to our data file and we're just going to check for structural errors in the data set. So things like, do all the columns have the same number of rows? So you're going to click on that CSV file, Resident Researcher Data. And then we're going to upload from GitHub. You could also upload similarly that Sally did for the data package from your local drive. But here we're going to click on that raw button. And if you try and paste it from here without clicking raw, you'll get an error. So click raw. You're going to copy this link. You're going to go back to Good Tables. And then where it says source, you could either click upload file if you're uploading it from your local drive, or you're going to paste your raw URL and you're going to click validate. And then here we see it says down below in green, valid table, which means that there are no structural errors to this data. But now we're going to check for content errors. So go back to that link on my GitHub. So you have that raw GitHub, you can click back. And here you see the way that my data set is set up. We have these different columns. Notice that there's some demographic data like age bracket, whereas grouping people into different age ranges or age brackets and age range. So we have under 35, 35 and older for this age range. And we see that that's a string and not a number. And that's important for what I'm about to show you. So we're going to go back to the main page of this repository. And we're going to grab, so if you see in the JSON file that has the metadata as well as the schema for this data set, starting here. So you would grab from here and that's where you would save it all the way down to here to just get the schema. Oh, sorry, all the way down to there. But I've already done this for you. So we're going to first look at an invalid example. So we're going to copy over this schema. And what's invalid about this is that under age range here in the schema, I've written that it's a number. So in the schema invalid JSON file, you're going to click that raw button. You're going to copy over that link. You're going to go back to Good Tables, and where you're supposed to upload the schema, you can copy it there and click validate.
Shout out to the sharp-eyed participant who caught that error even before.
Great job.
I know.
So here we see that there's a content error, and it'll show you that there's a format error in your schema, meaning that age range is actually a string and not a number. But then if you go back to my GitHub, and instead you click on schema, this is the valid one, this one that says schema only. You see that I have all the types of the different columns correct. In age range, we see string. Make sure you click raw again. Copy over this link. Go back to Good Tables. And here, instead of uploading the wrong one, upload the right schema and click validate. And now this is checking for structural and content errors. And we see that we get this, that this data set is a valid table. And yeah, are there any questions?
All right, we've got some questions coming in through the chat, so maybe as hope we can answer these. The question is, schema same as features, only difference in name. Might need a little bit more context to that question. And then another question is, what would be a valid NA for type number column? That might be more for Lily from the Open Knowledge Foundation.
Yeah, Ilya, maybe could you expound on what you mean by that?
I think what the participant mean is that, for example, you have a column that has numbers, but then within that column there are cells that don't have numbers, they're NAs.
Okay, I understand. That's a good question. So the default settings on Good Tables will find every missing value or every NA value and throw an error as a default to let you know that there are missing values. But you can change those default settings to ignore missing values, for instance. You can also change it to ignore other values that you might have. As a default, Good Tables will catch repeating values or duplicate rows. And sometimes you might have data that has duplicate rows for whatever reason, and you can turn off that setting on Good Tables as well. Other questions? I'm gonna check in the chat as well. But if you have a question and you wanna unmute and ask it, you can do that as well.
Yeah, I think there's a good one here that asks, when I share the data package as a whole, should I include both the JSON file with the schema and the metadata? I'm assuming this is, or the JSON file with the schema only. So yeah, we spent a lot of time, I think, talking about the importance of the schema. But I suggest that like the schema is really good for validation, but I think for like human interpretation, the metadata is extremely important. It's the metadata that's giving you that context. You know, if you have a column that says length, and you just have a column that says length in your CSV file, I don't really know much about that length. If it's a fish length, is it like the length from the fin to the front of the fish? Is it the fork length? Is it just to the caudal peduncle? So if you don't have that sort of context of what the length means, then I could interpret that differently, especially if I'm doing sort of like age to length regressions. So if you include that metadata information in like the description where you say length is the fork length, then I have a lot more information to go on and to be able to do my analysis appropriately with. So yeah, I suggest that when you share it, the schema is important for validation, but the metadata is really important for your colleagues.
Yeah, that's a great answer, Monica. Also, the tools that we're showing you today are fairly simplistic because we're trying to do, the beginner-friendly workshop. But there are more complex things you can do with the coding libraries, for instance, and you can really use that entire data package.json file without having to parse it yourself if you're using the libraries. So that's advanced work that if you get into that and you have any questions, please ask us on our Discord channel, or you can always email me or contact us another way, and we'd be really happy to help you figure that out. I'm going to share my screen again. All right. Were there more questions? All right, I think that we're nearing the end, so I will let the fellows take over again.
Okay, so thanks everybody. As Lily mentioned, I think an important element here is that we sort of just scratched the surface on the power of these tools. I think we sort of went through like the graphical user interface tools because that's easier to do in the workshop. It's also a great introduction to the power of these tools. That also means that if you're sort of beginning in your data analysis, beginning in sort of getting comfortable with data analysis tools or data science as a whole, this is a really good place to start. But that as you progress, you can go to the tutorials and learn more about the programmatic features that you can integrate into your workflow. Or if you're an advanced user, how you can use those features now and build them into any of like the Python or R libraries that you're currently using in your workflow. So we're going to keep the channel open for questions. I hope that this has been a really good experience and a good introduction. I want to thank all the fellows for all of their hard work over the course of these months. It's been a great experience. So it wasn't, for us, it wasn't just learning about the tools themselves, it was also about this like little community that we built as part of being part of this fellowship. So we did a combination of going through a syllabus, but we also had like weekly check-ins, and we had calls with each other. We did a couple of journal clubs. We wrote a bunch of different blogs about our experience. So if you want to know what it was like to go through the program and to learn about these tools, you can check them out on the Frictionless Data Fellowship website. So it was a great experience for all of us. I'm sort of speaking as a whole. I think we're all starting to get sad that it's the end of our time as inaugural fellows, but I'll show you on the next slide that if you're interested in learning more about these tools, really diving into them, and through the cohort model, so learning with other individuals and sort of being part of this community, the applications for the second cohort of the Frictionless Data Fellows is open now. So I highly encourage you to apply. Again, it's been such a fantastic experience for us. And on top of that, it comes with the benefits of like you're learning things, you're making friends, but it also comes with remuneration, so money. So that's pretty cool. Who can't use more of that? So I highly encourage you to apply. With this last slide, just showing you some important links. So if you go to our GitHub page or the Discuss pages there as well. We have a couple of YouTube videos that the Open Knowledge Foundation has put together to tell you about sort of walk you through the tools. The field guide is my favorite, so that's the second to last link there. It will take you through the tools and has tutorials on how to use the tool with dummy data as well, including some tutorials for the programmatic interface as well. And if you want to follow us on, follow the organization on Twitter, the handle is @frictionlessdata with an 8. Want to thank the Open Knowledge Foundation for this great opportunity. the Frictionless Data program, as well as Datatopian. I think there's a couple of questions that have come up about the program, so why don't we take those up before we conclude the workshop. So there's some question about the time. Yeah, I think that's been answered. Do we have any other questions that haven't been answered about the program?
A little bit about the application process. I understand. What does it require in an application to get selected? Lily?
Yes, sorry, I was trying to find the link to the Discord to let everybody join. There are a few important things that fellows need. They need to have some programming ability, but you don't need to be an expert in any language. You need to be familiar with GitHub because we use GitHub a lot. But again, if you are at a beginner level, that is fine. We will build up that skill together. You need to have good internet so that we can communicate because it's virtual. We pick people that are early career researchers. So as you can see from the current fellows, that means different things. Like you could be a graduate student, you could have recently gotten your PhD and be a postdoc or be in some other kind of postgraduate program, or you could be even like a very early faculty member, or you could be, somewhere in the middle. The most important thing is that you have your own data that you can use. Like Lily, she showed her data from her research, and in the program you will be using your own data. So that's very important. Another aspect is ideally you will be able to give a workshop to your colleagues, and with things as they are, obviously that didn't happen this time, so that's why we're doing the virtual workshop. But ideally you would have a research group or a lab or some kind of community that you can work with as well. See if I missed anything. I think that's about it. But if you have other questions, feel free to email me as well, or apply anyway. Let's see. If you have already applied, you do not need to apply again. The applications are open. I actually can't remember when they closed, but they're still open. And you should, I think there's an option when you apply to receive a confirmation of your application. So, it is ideal for you to have your own data to work with. And everything we do with Open Knowledge Foundation is open. And so ideally that data you work with can be publicly published or openly published as well. There are instances where, say, you have your own lab data and your principal investigator or someone doesn't want you to publicly publish that data yet. That's okay. We can work around it, but ideally the data will be openly licensed as well.
The application deadline is June 1st.
Thank you, Monica. And I'll try to do a quick turnaround of reviewing applications. Everyone that applies will get a response one way or the other. I'm trying to see if there are any other questions. Okay, and then I'm going to find that Discord link for people to join as well. We recently moved from Gitter to Discord, so it's still a little bit of a new system, but I think it's working pretty well. Here you go. We also tomorrow are having a Frictionless Data community hangout, and the information for that is in the Discord channel as well. And that will be 1 hour at I think 5 p.m. UK time. And people can just come and hang out. And then recently Gift and I think Gift is on here somewhere, have started doing Frictionless Fridays, where every Friday at 8 a.m. US Central, we are having a time where you can come and ask your questions on the Discord channel as well. So if you have questions and you're looking for a time to ask them, I recommend that you check that out. Okay. I think there have been more questions in the chat. The fellowships, when do they start? And yes, so they will start at the late part of summer, and then it goes for 9 months. And I haven't announced an official start date yet because that'll depend on, you know, who gets selected and their schedules, but late summer of this year, and then it goes for 9 months. Yes, summer Northern Hemisphere, thank you. Very, very, yes, thank you for calling that out. Yeah, another important thing is that I am based in the US Central Time Zone. So you need to have at least 1 hour a day of working time that overlaps with US Central Time. So Daniel Russo will tell you he did some late evenings with us trying to get us all matched up. So thank you for that flexibility, but that's also very important. Yes, so we're thinking July/August for a start. I'll type that in here for transparency. And yes, thank you for calling me out on summer. And we can hang out here for, I think we have this room for 12 more minutes if people have other questions, or if you want to try any of the tools with your own data and let us know if you have problems or if you can, you know, any questions at all. I can put my email in here too. Those are 2 places that you can reach me. Great, yeah, thank you so much to everyone that came today. And if you need to leave, please do. But if you want to hang out, I will hang out with you. Good question, Jackie. Let me see if I can find a blog post to tell you more about that work. It might take me a minute though.
Yeah, the workshop is going to be posted on the Open Knowledge Foundation website or blog?
On the YouTube channel.
On the YouTube channel, great.
Yeah. Manuel asks a good question. So that is the way that the Good Tables browser tool, or pardon, the data package creator browser tool automatically thought that the age range was an integer. And so that was a mistake, which is why it's important to always go through and, you know, double check as well. And yes, Sally put the link to the YouTube channel. I'm going to put the generic link to our blog into the chat, since it might take me a minute to find the blogs I'm looking for. Gift, do you have, if you're still here, do you happen to know where examples of that work is. I can't find it quickly. Well, off the top of my head, if you're still here, sorry, who asked this question? This is the bad thing about chat. I have to keep scrolling. Jackie asked the question. One way that government data has used frictionless in the past is with CCAN. And I'm not sure if people are familiar with CCAN. I can send another link.
You can go.
Nope.
Go ahead, I can find CCAN link and share.
Ooh, so we missed you, or you cut out.
No, I was just saying you can go ahead, I can find the link and share, but then I think it's already shared.
Oh, okay, thanks. Yeah, Jackie, that's definitely one example. Do people have other questions, other burning questions right now?
Maybe to answer one that has been asked by two people is the data format that the tools can take, the data package creator can take. Yes, it can take, apart from CSV, which is what we used, any data format that is in tabular form. So any spreadsheet formats, it could be JSON, and I guess an additionally for the programming interface. So mostly any tabular data format can be sucked in by the tool.
Another thing I want to note is that the Frictionless Data team has been recently working on improving our website and did a complete redo of the website, and Gift was very instrumental in that process. And we are still working on redoing our documentation. So if you use the tools and you have problems with our documentation, it would be very helpful to get feedback from users. We are trying to make them better and more clear for everyone. And I can put the link in where we have started a new guide section. But yeah, if you have any feedback, we would love to hear that.